Hi friends, welcome back to the second part, and I guess that all of you are quite prepared with the first part and you are very clear with the definition of sets and the representations we have done. In this part, we are going to start with some general terminologies related to the set, and mind it, this is going to be one of the important parts of this sets and relations, because the question from this specifically based on subset, superset, it's frequently seen in the JEE mains, and it's also important in boards, maybe in 1 markers and your further parts, which like the number of relations which you will be doing in the coming subsequent parts. So it will be helpful in that. Understand each terminology very thoroughly and pause in between if you require to recall the different terms. So let us start with the part and explore the different terms. Let's look at some of the important key terms which we are required to understand while we are doing the sets. So after understanding the sets, now what the set are, I guess all of you are clear about that. So now let us talk some general type of sets which are used, or some terminologies. So first one of them is null or void set. Now as the name itself is self-explanatory, that if a set contains no element. Now you will question me that, sir, you said that set is a collection of well-defined objects. So how come a set be an empty set? Okay, I also mentioned, like when we are using a set builder or any form, we are writing a statement, right? And based on that, in mathematics we are seeing that whether there will be any number or not. Now suppose if I say that A is a set of real solutions of the equation x square plus 1 equal to 0. The most common example, right? Most common example which all of you might be finding. So this is a null set. Why? Because there is no real solutions for this. So basically when we are talking about a collection, it's not necessary that it should be there, but it can be void also, depending on the definition. Like I can say that A is a set of students studying in 10th and 11th class. Now this is a null set. Why? Because you cannot have a student who is simultaneously studying in 10th class or 11th class. And again, either we denote it like this or like this. Never ever denote it like this. This is wrong. Now here phi actually becomes the element of this set, whereas only phi represents the empty or null set. Singleton set, again, if the set has got one element, it's called singleton set. Again, self-explanatory. Coming to the next term, finite and infinite set, again the names are self-explanatory. Now if the objects are having finite number, that is you can count the number of elements in a set, then that set is called to be finite set. So for example, if I say a set of current 15 Indian players of Indian cricket team, so you can easily pick the current and make a set. You can count, basically you are saying 15, right? You can say some set of 5 natural numbers, first 5 natural numbers. So that is also finite. But if I say infinite set, it means the number of elements, they are infinite, like set of natural numbers, set of integers, or many more examples can be there. Equal and equivalent sets. Now this is very, very key and important to understand that what this are. Okay, now very clear distinguishing, like when we are saying equal set, it means when you write the set after simplified. Now what do I mean by simplified here? Simplified form, it means like once you remove all the repetitive elements and all, so if you compare two sets, all their elements are same, then it becomes a equal sets. Now equivalent sets are those sets where the number of elements are same. Now this will be perfectly explained by an example. If I say A, B, C, D and D, S, B, C, D, A, C, S, 1, 2, 3, 4, D as 2, 3, 9, A. Now here see that if you see A and B, all their elements are same. Order does not matter. Let me be very clear with that in a set, it's just a collection, right? We are not interested whether a particular thing is coming, for the first time or for to the second time. So we just are concerned that the same element should be present, and if the element is repeated, then suppose if there would have been written ABA, then you would not have said that this has got 5 elements. First you will simplify, remove this duplication. You will say now this is ABCD, this is also ABCD. So this makes basically the two sets equal. Now when I talk about the C part, now C has not got the same elements as B, A or A, but the number of elements are same. That is AC or BC, these are equivalent. Now all the 4 sets are equivalent sets, okay, because the number of elements, they are same. It has nothing to do with the what elements are. The only thing it will matter will be in equal sets, that when the both all the elements are same, then you will say that they are equal sets. Universal set, now again a very important in context of whenever we will be solving the questions. So universal set is a set in context to the all sets which we are dealing, in context to the sets which we are dealing. It's a bigger set, or it's a superset of every set. Now what is a superset? Basically we will just see after this one. Like if I say that you are considering 3 sets, now universal set will contain all the elements of A, B, C, and it might have even extra elements. So universal set, generally if we are talking about numbers, real numbers, natural numbers, all these sets are universal sets with respect to a given context, okay. But even for a question 1, 2, 3, 4 up to 10, this can also be a universal set, provided no other set contains any element outside this particular set, then it becomes a universal set. Let us just look at the definition. A non-empty set of which all the sets under consideration are subsets. Now we'll be just discussing about the subsets, okay. It's called universal set, and in any application of set theory, all the sets under consideration will be like to be subset of fixed set. Like whenever we are discussing a question, all these sets will come for a parent set. That parent set is basically called universal set. Disjoint sets, when two sets are not having anything common, like I am saying that okay, this is an set of integers and this is the set of fractions. Now when I say fractions, I will say proper fractions, so that it will be value will be between 0 included and less than 1. So now these two won't have anything common, okay. They won't be having anything common. Like I can again say that set A is first 5 natural numbers, set B is natural numbers from 10 to 20. So these two sets will not be having anything common. Common means there should not be any element of A present in B or vice versa. So then we call them as disjoint sets. Subset of a set. Now this is a very key slide, and I would say that this is the topic where the questions are going to come for sure in the mains, okay. This is basically based on this concept only. It will be used in relations as well, and you will be finding this very often. The questions combined with binomial and this, they are always a favorite examiner's choice. So make sure that you do this very carefully, and this is one of the most important topics. Subset of a set means, now if you are taking a set, okay, any set, and you are picking some element from that and you make another set from that, that is basically called a subset. So basically you can say that a set is a father and a subset is a child, part of the father, okay, like that. And to denote subset, this symbol is used, okay. Now the one case where it will be strange to understand that a set is also a subset of itself. Why? Because you can take all the parts, right? Like if you make 10 elements are there in set A and you take 10 elements out and make another set. So that is also a subset, but that is not a proper subset, as we'll get to know. Proper subsets are only the sets, total number of sets, subsets minus the set itself and the null set. Now null set is a subset of all the sets. Basically, if you take any set, null set is gonna be subset of all. Why? Because that is, again, if you write 1, 2, 3, so you are taking the set which is included in this one. Included means it does not have any object other than this one. So that is where you need to think that, okay, subset is something which is smaller, like picking up elements, not anything extra from a given set. So this is called this, and symbol uses this. For proper subsets, this symbol is used. Strictly, we don't use this line. The only thing is used is this one. So basically, if X is belonging to A, if A is a B of subset of B, then X has to belong to B also. Superset. Now again, a superset is the original set from which a subset is formed. So if you are talking about a superset, it basically means the bigger one, like from the parent. Parent is a superset and child is a subset in a given context. So important tip here. Now each set is a subset that I already talked about. Also a void set is a subset. That's also universally true. Now if there is at least one element in B which does not belong to the set A, what does it mean? Now there is at least one element in B. Suppose I take B, 1, 2. If I take pick, this is not there in A. I say this is A, 1, 2, 3. Then we say that A is a proper subset of B. Means if a set is just bigger or just smaller than the other set, then in that context it will be a proper set. And the symbol used is this one. Yeah. And the total number of subsets of a finite set containing n elements is 2 raised to power n. Now let us take an example for this. Now if I take A is equal to 1, 2, 3. Now if I want to make the subsets of A, so I can take 1, I can take 2, I can take 1, 2, I can take 2, 3. I forgot 3 here, so 3 I'll also take. Then I can take 3, 1, right? Then I can pick all the 3 and the null set. So if you count, this will be 8, which is nothing but 2 raised to power 3. Now how does that come again? We'll learn it in the permutation and combination, that if you're choosing, okay, so basically each element has got 2 choices, whether to appear in the subset or not. So 2 choices for one, that whether it will appear or not, 2 choices for this, 2 choices for, so if there are n elements, all the elements have with two choices, that whether they will come or not. So if one choice change, it becomes another subset. So very, very important relation, this one, and this is frequently asked in the JEE mains, like very much common concept which is being asked. Okay, moving on to the next last definition or terminology, that is a power set. Now power set is basically set of all the subsets. So in the previous case, if I make, now this is already written here, that if A is 1, 2, 3, so we made 1, 2, these were the subsets, right? 1, 2, 2, 3, 1, 3, set itself and null set. Now if I put them as element, now there was no restriction on the element, right? That any element, it can be of any type, and any element we can put in a set. So if I am putting a set as an element, it basically becomes power set of a given set. Like it should contain all the subsets. Even if it misses one, it's not a power set. So clearly if A has got n elements, so power set will have 2 raised to power n. Now this is a straight application of the thing which we have done. So if somebody will ask you that how many number of subsets, you will be able to answer easily. But you must remember that this is indirectly asked always, so it might be in the form of power set. Like power set is also saying the same thing, but you must remember that power set is nothing but the combination of basically all the subsets combined. Now let us, okay, this one is the last one. After that, basically interval as a subset. Okay, now what is an interval? This concept is basically used in functions, but since we are going for the smaller, we are dealing with the numbers. So when we are talking about the real numbers, okay, now there are times when we are not able to describe or write discrete numbers. We want the continuation. Like suppose I want all the numbers between 1 and 2 in a subset or in a set. So I will have to write 1 point, there will be infinite numbers, so it's not possible, or I can at max represent it in the, suppose 1 to 2 I want, so I can put this as condition and x belongs to real numbers. I can write like this, but is there any better way? Yes, of course it is. So as I mentioned earlier also, like you must use the brackets very carefully. So this was the braces for set. Now for interval, basically when we are talking about real numbers, okay. Now whenever we are talking about interval means any part of the real number line. So whenever we are talking about the interval they will always be used for continuation of numbers, and they will be basically subset of real numbers. Okay. So whenever if I want to represent suppose numbers between 3 to 4, so I can write like, now this is the representation. Now there are again two kind of braces here. One is a round brace, other one is a square, and you can also use the combination of both. Now what does this braces stand for? Now in this case 3 and 4 are not included. This is interpreted as x is between 3 to 4. Now this is interpreted as x is less than equal to 3, greater than equal to 3 and less than equal to 4. This one will be interpreted as this one. Now you should understand that when I'm talking about interval basically is like it's given big thing, yes, cutting it into smaller. So one part you take, that becomes an interval. Now again, if suppose on a number line you want two chunks, so what you can do? Pick this chunk and you can write union this chunk. So again, intervals they can be used as sets, but the only difference is in sets you are choosing the discrete things, that is 1, 2, 3. You're mentioning the objects or elements of the set very discretely, whereas in interval it's continuous, like all over that thing, every possible number or every possible thing will be into the roll. Okay, let's start with some questions of what we have done. Very important things we have discussed in this one. Interval, which will be helpful in functions, while you will be going for domains and range, which we are going to also discuss in relations also, but that is majorly more important in functions, which will be a separate video. In this basically we are going to only cover about the sets and relations, and this is a part where we are discussing about some terms. So let us see our first question. Now it says two finite sets have m elements and n elements. The total number of subsets of first set is more than, the total number of subsets of first is 2 raised to power n, second one is 2 raised to power n. The first one is 56 more than the, first one is 56 more than the total number of subsets. Now this question again was purely based on that. Now we have to find the values of mn. The very quick way will be just substitute the values. Now if you are good in calculations, you won't be requiring that thing. You can just specify this as 7 into 8. Now this is what? 2 raised to power m or 2 raised to power n if I take common, it will be 2 raised to power m by n minus 1. Now this is same as 8 into 8 minus 1. So you can get n as 3 here and m by n as again 3. This will be 2 raised to power 3. Compare it, so you will get basically this thing. Okay, so self-explanatory, not very difficult. Okay, so this must be understood very easily, not a very difficult thing to understand. So Yes. Yeah. So this one you can just find, and the only step which you people needed is this one. Or if you would have checked for the options like 2 raised to power 5 is not going, if the difference is 56, it has to be more than 2 raised to power 6, the first one. So 2 raised to power 6 is 64 and this is minus 8. So this is a perfect example where you'll find the same thing, and this will basically be the right answer, B1. You can just check it from here also, simplification, or you can just substitute the values. Moving on to the next question, which of the following is the empty set? Now empty set, again we need to check, we need to form the roster form, and that's how we can check whether the set is an empty set or not. It's a real number, so from here you are getting real solutions as x is equal to plus minus 1, okay. And for the second one you will see that x square plus 1. So now this is a bit fishy, like we can't have a square real number for which the square is negative. So this is basically the empty set which I've given example while and making that understand in the beginning. So it must be very very clear that this thing is going to be important to understand the empty set and all, and it's very very important, like the usage of the different terms. Coming to the last thing, and this is a perfect question to understand all the concepts which we have discussed till now, the power set, subset, everything, okay. Now empty set, everything is clear in this one, okay. Now look at this set very carefully. This is phi. Now see, here all the usages of the phi you will find. Now phi as an element is present, phi as an element of a set is present, and phi as a subset will also be present. So all the basic concepts of this thing will be used. So what will be the elements of this one? Basically phi is an element and set of phi is element. So subsets will be, first we will be taking individual elements. Now please carefully note the braces, okay. Then there will be a subset which is having both the elements, which is the set itself, and then you will have phi only or empty set. So this is phi as an element, phi as a part of set which is an element, phi as a subset, and this one is. So very very good question to understand all the concepts about phi. You hope, like, if you follow this one clearly, then you will be easily able to distinguish that when we are using phi is basically a symbol, right? So symbol, if we are using it as a symbol, it represents a null set. If we are using it as an element, like we use A, B, C, D, then it's the same. And if we put it in the braces and make it as the element of a set which is itself an element of another set, so that's also we can also use. So very good question to understand all the concepts about the power set and all. So C will be the correct option for this one, and I hope that you have learnt quite great deal of the different terms. I hope that you all are clear with different terms, and as I have mentioned, these are very important to proceed further. If you have not learned it, stop here, watch it again and then proceed. In the coming parts, we are going to see the pictorial parts of the set, and that are very interesting to solve, and the questions will be very very interesting from that part. Stay tuned for the next part.